Mm.
Good morning to all of you.
Okay.
Today I am going to deal with one of the fast evolution technology called the quantum technology, quantum computing. And we are not going into the deep, just you will be introduced to the concepts and definitions. If time permits, by today evening I will show few programs. Okay, anyhow, you'll learn later also. That is not an issue. So, without any ado, we'll start with this presentation. If you go 80 years back or 100 years back, how the normal computer, that means what we are being using, it is the size of this one. This was introduced in 1945 by IBM, because IBM is the inventor of these computational machines. At that time, what we'll call it as ENIAC. Okay, these are mainly used for doing some basic calculations, like multiplications, whatever we'll do when we learn in elementary school, those type of calculators. And the size of, if you see this size, how it is, the weight is 30 tons and power consumption is 150 kilowatts, and it works on 5 kilohertz, and this is the space requirement for to accommodate that machine. Now, apart from this basic numerical calculations, after 2 or 3 years, what IBM has done, they have modified this one to collect the attendance of any factory or any industry person. Suppose only those times these attendance calculations were called punch recordings. See, 2 years before it was only for basic calculations, and after 2 years they have expanded the application of this computer, of this machine, to attendance calculation. Then and this is how your mobiles will be can be recorded. If you have your mobiles in your hand, the world is in your hand. Okay, and the size has been diminished very less, and the weight is also very. If you see here, only 100 grams of weight. That means, as because of why this has been drastic change has happened, because there has been change in the chip design. What in 1960s, one of the innovator, that there is one Intel founder called Morse. He has given proposed one law called Moore's law, where he predicted for every 2 years, because of increase in the complexity of data, your computational resources will keep on increasing. That means your chip design will keeps on the chip, where chip is made up, you all of know chip is made up of the transistors, and that in the chip more and more transistors will be incorporated, and because of this chip incorporation, the heat is evaluated based on the, depending upon the complexity of the data. Then that heat will keep on interacting with all those chips, all those transistors, and new quantum phenomena has been changing, that has been led to this quantum computer. We will see those everything in the next few slides. And before going into the inner details of those phenomena, these are the different trends that has occurred over the past 80 years. And this, so far what we have done with the classical computing. That means all your laptops, desktops, and even your mobiles, where everything will be happening here. And this quantum computing is the new phenomenon which we will discuss. This neuromorphic computing and DNA computing, these are mainly used for genetic engineering. That means to study the genetic disorders of human beings, not only human beings, anything, any other animals also. And the exascale wearables, and these are all many, they found they are using very less. They have their applications in very less. We will neglect that one. This DNA and neuromorphic computing is mainly used by the biotechnology company. That means to study the genetic engineering and to, you know that what are the CT scans, NMR scans, all those are working on this neuromorphic and DNA. These are all the different types of technology. Now these are the, let us shift to this our core topic called the quantum computing. And these are all the various types of quantum computers available, and actually these can be classified into gate-based, trapped ion, topological, photonics, and neutral atoms, and annealing. And these are all for every type of technologies, there is behind that one we are having different types of phenomena based on which these are all made. If you see among these ones, this one, gate-based quantum computers are predominantly used for calculation purposes. Trapped ion also used, and this topological, these are always least used. But when it comes to quantum annealing, these are used only for machine learning, for whatever the optimization problems are there. That means in machine learning will deal mainly with optimizations. Those type of things will be done here. You will learn in the next, in this 5-day session, you will learn about hybrid one, where you will be introduced with what this one means. What is quantum annealing? This D-Wave means is one company that is mainly using this quantum annealing. Okay. Now this one we will see about. We will be introduced about IBM Q. Now this is the Moore's law. See the observation. This is just before 2 slides I have told about the Moore's law. What he has told is, for every 2 years your computational resources. What is meant by computational resources? Your RAM, your hard disk drive. Well, these are the main things. RAM and that means processing, the resources which will be used for processing your data, that we will call it as quantum resources. If you simply see, let me give me one example. Suppose if I want to perform one calculation 210 into 210, that is simply a mathematical multiplication. What it will do? It will convert that 210 into binary bits 0s and 1. Similarly, another 210 into another binary bits. Then they are using AND gate, OR gate, or NAND gate. It will evaluate the result, and once the evaluation is over, it will be the result will be displayed in the form of again in decimal systems. Suppose if my problem is I'm having one picture, suppose, and I want to modify the picture, then how will you do that one? Because the pictures, first what it will have to process your data, what it has, that data must be converted into the binary systems. But 210 into 210, okay, it is a directly convert. You can directly convert into the decimal system. But what about the picture? To process any picture, what you have to do? First, you have to convert that one into the binary notation. How will you do that one? First, that picture will be represented in the form of pixels in RGB, that means red, grey and blue scale. For every color, every color will range from 0 to 255. That means for single pixel, you will be having three representations. For one for red, another for green, and the third one for blue. Suppose if my picture consists of 100 pixels, how many RGBs are there? For each pixel you will be having 3. For 100 means how many? You think of how the complexity has increased. It increased that drastically. So to accommodate that one in your circuit or in transistor level, you will require a large number of transistors. That means the process of converting your raw picture into binary representation, that is called the encoding one. You will call it as encoding. And in QML, that means in quantum machine learning, you will learn different types of encoding processes. Okay, once you convert this one from pixels into the binary representation, then by applying several algorithms, you can morph the picture. You can either enhance the picture or shrink the picture, you can rotate the picture, or if there is any unwanted noise is there, that means blurring is there, you can remove those blurring, everything you can decolor it or you can add color, all this you can do that one. As the complexity of data increases, please keep in judgment. As the complexity of the data increases, your computational resources will increase. As the suppose if I want to perform I'm having a 4 GB RAM computer and I want to perform this raw data which is in the form of pixel, which is picture, then to perform this one using the 4 GB RAM means it will take enormous of time. That means to increase this one, either you have to bear that amount of time, you have to wait till that processing is, or the second way is you can increase your RAM. See how this complex data demands your resources. That in 1965, this guy Moore has predicted that the number of transistors on the microchip will keep on doubling. And as the data, as this computation is being applying to several applications or several domains, these resources keeps on increasing. As you embed more and more transistors in the chips, because of the heat and heat exchange between among these transistors, new phenomena was observed, and that lead to the rise of this quantum computer. Okay, this is what the Moore's law gets, and this is what we are doing. If the size of the transistor is less than 7 nanometer, then these phenomena which are not visible to our naked eye will surfacing onto this one, and they produces the noise. The output of because of this noise, your output is not intended. What the output you should get, you are not getting. Okay. And one more thing, in 1988 or 19, in Cleveland Clinic is there. That is one of the best hospital in the world. They have designed one cancer prediction machine. I don't know the machine, because of this increase in the computational resources and the noise induced by this phenomena has led to the death of 40 people. That is from that point onwards, the Cleveland Clinic has started their own research lab for healthcare. What is it? Okay, and here what is meant by quantum tunneling? Quantum tunneling is one of the main topic which keeps on coming. Suppose if you have a ball and if I hit the one to the ball means it will come back, because ball is visible to us and the ball is having some mass, and by throwing it will hit that barrier. If you hit any barrier, not only the ball, any barrier, it will come. But at quantum, if you have small subatomic particles, if you hit that one means by power, if you have a beamer which fires the photons, and if the size is less than 7 nanometer means without coming back, it will flow outside the other side of the barrier. That is called the quantum tunneling. Here keep in mind, first only blind thing. We are not discussing about the big objects which we can see. We are all the quantum computing or even quantum mechanics itself will always deal at the subatomic levels, which is not visible to our naked eye. Okay, that's why if you see in +1 and +2, if you compare the +1 and +2, in the +1 physics we will discuss about the classical mechanics only, where the objects are visible to us. That means projectiles, cars, trains, everything we can visible to us. But when it comes to the second year, where we will deal with the waves, photons, optics, electromagnetism, electricity, conductor, inductions, everything it is not visible to us. And anyhow, I too have by what we call mugging the subject, I got positive. Okay, yeah. But here, once you are in engineering means your study should be entirely your focus must be in the practical one. You should think in a practical one. Okay? And here quantum computing is a subset of quantum mechanics. And quantum mechanics deals with the particle level which is not seen by our naked eye. Even not the particles, subatomic particle levels like of bosons, quarks, like that. Even so in our +2, what we are atom is there, or within the atom it will be surrounded by electrons, photons and neutrons. Even if you go inside that one, there are new particles called the bosons, quarks, some other thing. We are dealing at that level because we cannot see what will happen. And anybody who says, I know quantum computing or I know quantum mechanics 100% means blindly reject his claim. But straight away you can reject it. Who knows? Suppose today if I have one superposition, means tomorrow there may be some others. By doing researches you may observe another phenomena. We are dealing with the deepest level. We are going into the deepest level, not at the abstract level. This is what. And this is how quantum computer is. This is how quantum computer. To buy a quantum computer, it will cost you 120 crores. That means for $15 to $150. $1 million, sorry, not dollars. This is how the quantum computers are. And let us see what is the difference between the normal conventional computers like your mobiles or laptop and this one. Okay, before going into that one, let me introduce a small analogy. Suppose if I have a coin and the coin is having either head or tail, okay, and if I toss this one, means once after hitting the ground, if you see that one, you will get either head or tail. Okay, beyond that one you won't get it. And that means it is a deterministic, either head or tail. That is called seeing after hitting the coin, after the coin hits the ground, what are the values is there. That one is called the classical computation. If you toss, when studying the coin when it is spinning in the air, that one we will call it as quantum computing. Okay, while spinning we cannot predict what it will be. When we catch a coin at that point of time, it could be either head or tail. We don't know. After seeing that one only. And this one is the deterministic one, either head or tail. You will get only things, either head or tail, or either true or false. Or if you switch on, switch off. Only these two things. Deterministic. You can directly say whether we can directly say based on that set of the result, you will get one set. But you cannot tell beyond that one. But here in quantum computing, if the spin is spinning in the air, that means it can exhibit both values at a time. Suppose if coin is in this position, means it can be either probabilistic nature. It can, once if you see here, based on the position, you can tell what is the probability of getting head or what is the probability of getting tail. That here, whatever the position that is exhibiting by the coin in the air, that one is called the superposition. That means it can at every point of time when the coin is spinning, it can exhibit as a combination of head and tail. That is called the superposition. That means here in normal conventional computer will work only on the classical mechanics. Classical mechanics that was proposed by Isaac Newton. But here in quantum computing, it works on the principles of quantum mechanics. That means normal quantum computer, whatever the laws you studied in the +1 physics, that all related to especially these moving objects, projectiles, or those are belong to the classical computing, and in the second year of physics, what you study, that you can correlate with quantum computing, quantum mechanics. The quantum mechanical principles are used here. That is one thing. And the second thing, this is the mathematical, the second bullet mark, that is quantum computer operations are based on the linear algebra, whereas classical one are based on the normal Boolean algebra. What is the difference? Any idea? Boolean algebra means what are the different types of gates. If anybody from electronics and electricals, I think students are mainly from first and second year only, I think. Okay, no issues, you can learn that one. Here, that is not necessary, but we can correlate when we go into the advanced concepts. There we will learn what is the how you can correlate this Boolean expressions to the linear algebra by when you go into the gate designs. For the time being, it is not necessary. Just keep in mind that classical computers mainly works using Boolean operations. Boolean operations means what are the Boolean operations? At least you should know true or false. True or false. How can you define the true or false? Okay, using gates. What are the gates? AND gate, NOR gate, NAND gate. Using these 4 gates, you can solve any complex data. And especially using NAND gate, using the NAND gate, you can express the OR gate, AND gate, NOR gate. You can do anything by using different combinations or combination of these 4 gates. Okay, and here we are using only binaries, zeros and ones. That means when the coin is on the ground, either 0 or 1 or head or tail. We are not talking about what is happening in the space. What is happening when the coin is spinning in the space? Okay, we are talking about what is after hitting the ground, what we are getting. That means after applying the AND gate, NOR gate, OR gate or XOR gate, what is happening? Okay, here we are talking about what is happening when the coin is spinning in the air. That is the one thing. And the third one, building blocks of quantum computer is qubit. What is the normal computer? Whatever the data you feed into the computer, that means before going into this one, what I will tell you, what is happening. Suppose if you write a program that is visible, suppose if your teachers are there, sir, any faculty is there. Okay. Suppose if you write a program in Java, in high level program, actually computing programmings can be classified into 2 types. One is called the high level programming and the second one is called the low level programming. In the high level programming, the languages which you are using like Java, .NET, Python, Ruby, Perl, everything will fall under high level language. And the second one is called the low level language. That we will call it as assembled language. Now what will happen means, if you write your program in the high level program, using high level language, there is some instructions, statements, everything you can write just by using. Once this is being fed into after that, what it will then, it will be, went for compilation process. Once compilation is done, then link editing is done. After link editing only, you can run your program. What after compilation, you will get what? You will get the code. That one is called the low level. That is the machine instructions. Previously, before the advent of this high level program, whatever the programs at that time of they are using the program using chip level. Those languages that are used for writing programs at chip levels are called assembled languages. Okay. Those assembled languages, what it will do, these circuits, the transistors will convert those into what are the instructions or data is there into zeros and ones. Those are called the bits, bit 0 or bit 1. Group of bits are called bytes. Like that you can go through. The analogy for bits in quantum computer is called the qubit. And since we are studying the coin spinning in the air, it can take any value, both values. That means zeros and ones means we cannot use directly this binary system. We have to use some other mathematical framework which we called it as linear algebra. Okay? Here. And the bit is called, the bit in classical computer is referred here as a qubit in quantum computer. That means in normal classical computing you will be having bit. The analogous to the bit in quantum computer is called qubit. There you will be having either 0 or 1. Here we will use it vectors, and it can be either having 0 or 1 or both. Here and in classical one, what we will use gates to manipulate the bits. Here we will use gates, X gate, OR gate, NOR gate. Here we will use gates only, but in the form of matrices. And you will learn how to develop those matrices. Since there, and what about the fourth one? Here we are dealing with at a subatomic level, which means even a small change in the ambience, like temperature or some magnetic reflections or some other if there is small change in the ambient conditions, means they have huge impact on this one qubit, so that they can lose their information. That is the main drawback so far the industry is facing. They are doing by using some other to reduce those losses or noises. They are using the error coding. That is advanced one. You just keep in mind there is what topic called error coding. This is 15 millions to 40 millions it will cost you to buy this one. That means if you take $1 as 80 rupees, 12 crores to some 40 million. And since it is very cost, how can we run our programs? That is the meaning. We can use using our normal computers by using the cloud resources that is being provided by the IBM. We can run our programs on the quantum computer. Please ask me if anybody is having any doubts. Don't worry, the topic is weird, and as you keep on learning, you will get accustomed or habituated to the concepts as well as internals of this entire things, either at hardware level or at a software level. You can think of this one. as a here. Digital computers means how now this is the circuit. You can think of the circuit having several transistors. A circuit, not circuit, chip. Chips having this dot, blue dots are called the transistors, and how they are interacting. And here you can think this electron. This electron, I told you, no, anybody, if you correlate your this coin analogy with the electrons, means electron is having spins, right? Spin up, spin down, or plus minus half spins. If you correlate like this, means plus of and excited state. In chemistry, you call it as excited state, ground state. You can correlate those things like zero, ket 0 and ket 1. We'll see what is meant by ket and what is meant by bra. Okay, like this you can do. And if you see here, this is a weird notation. This ket 0, this notation, vertical bar followed by the greater than. This is called the ket notation, and between these between these two, you are placing 0 means it is in the ket 0 state, and that means 0 bit. But here in the form of vectors, column vectors. Similarly, this one, ket 1, 0 there in normal classical 0 will be there, but here it will be in the form of vectors. Keep in mind the state will be in the vectors. And what are the manipulations you are doing will be the matrices. And this is the visual represent. How can we visually see these qubits? You can think this qubit, you can represent graphically as a sphere, just like a ball, by having the south pole and north pole. South pole pointing to the state 0 and the north pole being pointed to the state 1. This one. This axis is called z axis. We will see later because you will be confused if you go into the inner details. What is theta and psi? Everything is. Once we go into the deeper mathematical framework, there we can learn about this one. Okay. And just like the transistors, you will build. How you will build it using? You will be having some Intel in normal computer. What Intel chips is there? They are giving some names, generations, like that. Similarly, here we have to build the qubits. How can we build it? These are the various types of ways we can build this one. In this one, superconducting quantum computing. This is one of the best one, but to build this one using this technology is cost you very high. To set up that environment itself is very high. Trapped ion, photonic, and quantum dot is nowadays getting the pace. And coupled quantum, these are all not there. This NMR is used for. This NMR and the NMR K quantum is mainly used for healthcare purposes, for health, to scannings, X-rays, to build those, to incorporate your qubits in that machines. You will use these things, and these are all still it is going in the nascent one. They are doing the researches. Majority of these things, this one. And photonic also. These are different types of ways how to build a quantum computer. This is Richard Feynman. I had already told that if anybody can claim that he knows quantum mechanics 100%, means please don't accept him. The mechanics, quantum mechanics is itself a weird. It is not obvious to everybody. And just like the desktops has the architecture, this is the architecture of our desktop, which you can classify into the various components. Similarly, we will be having the same architecture in the quantum computer also. The only thing is here processing work things will be different, because processor is entirely different. It makes use of linear algebra. Here it is using the Boolean algebra. There you are using linear algebra. Apart from this, and the architecture itself will be changed because of in the next slide you will see what it is. This is how the here your data center will be there. How a typical workflow will flow, how data will flow from your data center to your quantum computer to a quantum processor, and once the data is processed, how it will be given back to the user, and then how it will be stored in the data center. Here this is the normal data centers only, and this one is your normal computer only. The thing is, here what it will do, data will be converted, will be here. Here the data will be presented in the form of binary data, you know all of that one. And once it comes here, there will be encoders. Encoders are electronic converters that will be those zeros and ones. The binary data which is entering here will be encoded in the form of states or in the form of vectors. This is the main area. Lot of, if time permits, I will show you the different types of errors that will be having in this quantum computer. I will show you. Once here encoding is to happen, once it is encoded, that will be sent to various components, and this is the place where RAM or quantum processor is there. Here is the place where your quantum computation will happen. Once quantum computation is happen, the data is sent back in the form of vectors, and again it will travel here. There these vectors will be decoded back, and it will be centered in the form of binary values. This is the main part. And what about this one? This is the refrigeration shield. Because I told you that the subatomic particles, if there is a small disturbance in the environment, will alter the properties of those subatomic particles. In order to, once those properties changes, means your data will be corrupted and you will not get the intended results. So to prevent that data corruption, or to prevent your data and your processing unit from the environmental disturbances, this entire setup is insulated by a chamber called the refrigeration chamber. And to keep the to keep intact, what it will do, this is the coolant which will pump always the refrigerant coolant, so that the entire structure will be intact. Any environmental disturbances will not impact on this structure. Because of this one, all normal refrigeration coolants will not use, they are using cryogenic one. Cryogenic refrigerant coolants were generally used for space applications like rockets. Though because of that one only, the quantum computer costs you $15 to $40 million. Any doubts? Shall I go to the next? This is the variance, how you will compare the classical and quantum. This is the first three, that means fundamental unit. Here in classical one we will call it as bits, zeros and ones, and here you will call it as qubits. And the second one are operations. What type of operations we will call it? We will call it as deterministic operations in classical computing. Here we will call it as probability. Of course, here parallelism is there. That is very different. That here, suppose if you have written a program in Java and your input consists of thousand records, and your Java program has to process those 1000 records, means what your program will do? Your program will process one record at a time. It will not, but here because of this parallelism, your quantum computer, based on your problem definition and the complex of the data, it can process more than one record at a time. Even it can process all records at a time, and that all records, in order to process all records at a time, again your architecture should be changed. That means your qubits, number of qubits will be changed, and as the number of qubits changes, your gates will keep also, the size of the gate will keep on changing. That we can do. We will see later. And mathematical we have seen of the Boolean thing. Here we are using linear algebra, and this parallelism using you can do parallelism in normal computer by using multi-threading. But here we can by using the quantum parallelism, you can see we can process all those. To do multi-threading means again your computational resources will increase. Here we will use the parallelism concept to process, and this superposition we will see entanglement. And what about the energy conversion, consumption is relatively high in classical one, potentially lower consumption. And scalability also we can, as the scalability means how your architecture will change based on your complex requirements, complex data. This is the timeline. Even the quantum mechanics itself has started as these quantum phenomena. Scientists are able to identify all these phenomena from 18,000, and still they are doing this one. And this is how the quantum mechanics evolved over a period of 2 centuries until date. Just go through it, and it is not already this one. This black body radiation, Planck's constant, discovery of neuron, Dirac notation we will see in mathematics. Okay, wave particle theory, all these except Dirac notation, all these remaining 4 things you are already familiar with when you have learned in +2 physics. Okay, and this EPR paradox, Schrodinger's cat, and logic, quantum logic we will see. Quantum tunneling, what I have told is by throwing the ball or to the barrier, it will come back, but when you throw a small subatomic particle, it will go outside that one. Just like say, think about it, if you shout from here, somebody else who is staying outside the room, if they can hear your sound, means that is, even though there is barrier, they can hear. Why? Because of quantum tunneling. Okay? And quantum machine learning, this is something you will find a big application. Whatever the any AML students are there? Artificial intelligence or machine learning students? No, nobody from AML? Huh? Nobody. All are from? Easy. Yeah. DS. AIDS. Okay. AIDS artificial one thing. AI means artificial intelligence. Machine learning is a part of artificial intelligence. That means you should learn. You will learn. You are familiar with machine learning also. Okay. Okay. All the AI problems. Say I am going to remove this ML. All the AI problems can be solved using this one, quantum. Here we'll call it as a separate branch called separate branch dichotomy. We call it as QML. Just like ML, machine learning, we'll call it a quantum machine learning. Same thing, whatever the maths you will learn there, same maths only we are going to use here. But here in machine learning, there are two types, evaluation for two steps mainly. Evaluation, within the evaluation again there are several steps. Evaluation and optimization. Evaluation and optimization. Think how QML will go means, evaluation will happen in the quantum machine, quantum computer, and optimization will happen in the classical. That means we are using both quantum computer as well as your normal conventional computer. These type of models we have called it as hybrid models. There is one session which will be delivered by today or tomorrow, I think so. Here, that is called the quantum machine learning. That means you can use for calculations purpose. Why you are using for calculation purpose means because of parallelism, quantum computers are fast in nature. Suppose the quantum computer can do a complex problem in matter of seconds or in matter of hours. That's it. That the same problem, if you want to process in the conventional computers, it may take, you don't know, if it is a complex number, it may take several years also. And the simple thing, all of you know the chess, right? Chess, there will be two players and 64 checks. Okay. Suppose if you want to play if you are playing with a normal computer means based on your step only the computer will perform accordingly. But here for every step, once suppose if I move one step, based on this move, it will think in a way such that in how many ways in this current step, how can I check the opponent? That means for every step it keeps on calculating. For every step, how many different ways it evaluates different ways. And if you think I have a program, I'll share it that one. For every step, it will show you 1.2 billion steps. It can evaluate 1.2 billion steps. So that in its chance, it can check you. And maze problem, maze problem. Maze problem. This simple. You will be given some maze is nothing but you have to find the route. There will be several obstacles. There is only one solution. That also I will show. I am having that one. I will share my GitHub repo so that you can go through it. That is the QML. optimization, and optimization problems are mainly used in where? Suppose in chemistry, high energy physics level, if physics is there, means engineering has to be there. Suppose in chemistry, especially in drug discovery, before going to, I don't know about that one, you are having, suppose how water is formed, water molecule is formed, by if you react 2 molecules of hydrogen with 1 molecule of water, you will get 2 molecules of water. 2H2 plus O2 gives rise to 2H2O. So before chemical reaction starts, hydrogen has its own physical properties, chemical properties, as well as oxygen do have the same. After interacting, after chemical reaction starts, there will be some certain point of time for which you have to wait till you get the water molecule. That means before, at the starting point of chemical reaction and at ending point of the chemical reaction, these 2 hydrogens and oxygen molecules will keep on changing, right? Properties will keep on changing. What quantum computer is, they can extract all those properties, what are the intermediate states are there, using those states by combining with other chemicals, they can extract they can find the new molecules also. Especially drug discoveries are very, Madonna is the company which is using this quantum computing to evaluate, to find the drugs as fast as possible. They are incorporating this one. That is one thing. All those are optimization problems only. And what is meant by quantum teleportation? There is one circular in the last final lecture you will be having some space, madam has told, space series, how you can use the quantum computer for space. There you will see what is meant by quantum teleport. Teleportation is nothing but transferring your information from one place to another using in a secured way. Those you will see. This is the quantum teleportation. And these are entanglement operators are, when we go into the circuits, you will learn that. And this is the timeline of how, over a period of time, how from 2010 to 2023, how the quantum computing is evolved. These are not necessary, but for information purpose, you can go. Anyhow, I will share this one to all of you. And this is the market trends. There are several quantum startups which are mainly focusing on this quantum computing. Okay? In this one, IBM and the few companies which stood for runner is the IBM. They are spending billions of money throughout the world. And some other these are all the few. And how this quantum users, application, software offering, QPs. These are the main, especially these hardware components. These and QPUs are the main areas. Majority of the startups are focusing to increase this fidelity level, since it is quantum computer works on the probabilistic nature. That means probability means chances. We are not getting the 100 per deterministic values. To increase our expected results, or to increase the fidelity level of the computer, majority of the investment has been occurring here in QPs. Okay. this is how our India's nation, how Indian government is spending. They are spending $1.5 billion and only to prepare the students to build the quantum force or quantum research, just like how software engineers are there. Similarly, government is aiming to prepare the quantum force, keeping in view of the future demands. And the government of India is spending $1.5 billion. Okay? And these are the few companies which I already have started to enhance skills to their employees. And these are the institutions. In these institutions, IIM, IIT Madras and IISc and IIT Delhi. These three institutes are very well. They are conducting several online programs or offline programs as well as workshops. This is the, if you think about in the global perspective, these are the various things. Various countries, how they are 36. This timeline is for, I think in 2024 only. This is the $36 billion. Sorry, in 2023 they have spent up to $36 billion. Now they have increased this one. And please come out of the mind that quantum computer is subjected to only for computer science. It's not so, because we are dealing with the subatomic level. That means everything. Even if it's one small example, suppose if you get a fever, you go to doctor and he will give you medication for 3 days. If fever does not reside, still it is there, then he sent you for some blood tests. That means first what he has done, based on the temperature, he has given the temperature. Now after that what he has done, he is going into the blood level, how your blood changes. Whether you are infected with malaria or dengue, you want to study that. That means his focus will go somewhat deeper. That means he is falling into the atomic level or subatomic level he wants to study. Right? That means the entire universe is made up of subatomic particles. Means nothing, it can be applied in any field. It does not matter whether it is a computer science, whether it is a mechanical engineer or space technology or healthcare, chemistry, even in civil engineering. Suppose if I want to know when this building how long this building will sustain, you can study those. But the thing is, you need to grab the properties, convert the properties into the states, that means in the vectors, then applying the operators. The main thing is, and again, only these programmers cannot solve there are divergent requirements. Okay, to collect the data, you need, suppose if you want to study the lifespan of this building, means you need an engineer, civil engineer. You need a civil engineer, you need a structural engineer, and again you need a metallurgist who studies of the steel, like that. And once data is collected, based on the data, to design these circuits, you need mathematicians. Okay? Once that is done, your circuit is done, you need to write a program, their programmer will come into the existence. And the programmer cannot, just like Java, they cannot do that. You cannot write the program. I'll show you a small program. First year students, all are first year students. Data structures have you studied? No, okay, you'll come here. You'll be introduced that one. And think stuff is there, no? In data structures, what we'll do, suppose if you take a linear sorting, there you can do that one. But here in quantum, I will show you the program where you will use the operators that is entirely dependent upon the problem definition, not on the, it is not on the way how you will do sorting or searching in normal classical way. Okay, that means the entire quantum ecosystem will be based on, it is not a single individual. You need to have subject, domain specific experts, physicists, mathematicians, as well as the programmer. The programmer you cannot do. You should learn all these concepts. Unless you know all these concepts, you cannot become a sound quantum programmer. That I am sure. That means it is having it. But physics and mathematics, without having the programming language, they can give you the solution. But the programmer must know about this entire thing. And this is first thing, artificial and machine learning. These are the applications where you can use this. Artificial intelligence and machine learning. And machine learning for optimization problems only we will use. Okay? Computational chemistry. I told you about how on react, how can you extract the intermediate properties or states of how these participating molecules changes as the time progresses. You can study all those properties or chemical behavior of this one. Drug design and development both are same only. Cyber security and cryptography. I think there will be a small session in this Fdp session only. There you will learn about that. Financial modeling. As I told that it is not only related to quantum, it can be given in any field. And in one of the field, this is the financial modeling. JP Morgan and Wells Fargo, these two are the two major banks. One of the major banks in the US, they are using this quantum principles, and they have developed an algorithm. They are making billions of money only in option. That again it is a different story. That is a share market. There is generally if you want to buy shares, generally what people will do, buy shares at the last price and they will sell more at when the price increases they will sell and they will keep the profit. But within the financial markets there are one derivative section is there, derivative trading. In that derivative trading, again the entire derivative trading is divided into major classification is there, and within that one there is, I will tell you, one futures trading and options trading is there. Within the options trading, options trading is a very complex trading methodology used by only subject experts or trading experts. What generally normal like us we cannot trade, because it is just like you will be having, if you have a ice in your hand,
if you hold that ice for some of time, keeps on decreasing, keeps on melting, and you will get to the water. At one stage you will not find your water also, because water will flow out of your hands. That type of complex is that means if you put your money in the options trading means you will see your money will keep on going out of your hands. That type of complexity, they have JP Morgan and Wells Fargo have devised quantum algorithms, and they are making a lot of money. Okay, see how for that one subject matter, somebody who knows about how options are going on, they should know. They should develop using the mathematicians and using those options specialists. They will develop one algorithm. That algorithm will be given to the quantum programmer. Their quantum programmer will write quantum programs. Those programs will be tested several times, or once results is expected, then they will go for actual trading. Like that they are using this one. And logistic is nothing but the maze problem. If you know about the maze problem, and if you write a problem, that you can correlate with the logistic optimization. And weather forecasting. How based on the here what it will do, again here they will collect all the parameters. What is the humidity, what is the temperature, everything will be collected, and how this based on the temperature, how and based on the seasons, based on the wind flow, all these parameters they will collect and they will study. Based on that one, they will generate the algorithms, and again they will be sent for that program writing. They will test it. Like that, all the complex things can be easily done using quantum. Why? Because of the two major phenomena. One is called the superposition. Superposition is called studying the coin when it is spinning in the air. Okay. The second one is entanglement. Entanglement is nothing but what I will tell that. In subatomic particles, what they will do? If suppose two subatomic particles will interact with each other, what they will do is they will exchange all their properties with each other. They keep their properties, their own properties. Apart from that, they will extract all the properties of the second particle. That means they have increased their properties. Now, once they interact and they far away separated, then suppose if A and B are two subatomic particles, they interacted with each other and separated. That one is called the entanglement. Interacting with each other, exchanging all these properties, and they keep on being separated. That is called the entanglement. And the entanglement, this property what it will have. Suppose after interacting one particle, say A is very nearer to you and B is somewhere it is in the Mars. Then the beauty of this entanglement is by studying these properties, you can study those properties. That is anyhow, while interacting you can get it. But the thing is, if you apply some manipulation gates, or if you change the properties of the particle which is nearer to you, the same properties, the same changes will be exhibited in the far particle. That is called the entanglement. And this entanglement is used in the quantum teleportation, cyber security, and super dense coding. Super dense coding, all this we will see. Just familiarize yourself with this conception, at least with the terminology, not with the full understanding. And these are the various programming frameworks. Qiskit is the one that is developed by IBM. It is solely written on the Python, and users will develop the quantum program using Qiskit, that using Python only. And and keep in mind that we are dealing at circuit level. Okay. Now IBM has their one more program has evolved for 4 to 5 years back. That one is called Rust program. Rust program is far more superior than the Python, especially at the circuit level. So they are slowly what are the new functionalities they are adding into the Qiskit APIs. They are developing using Rust program. But as high level, you can use your Python program. That's not an issue. And Google's framework is the program framework is the CARC, C-A-R-K. And this is also developed on using Python only. Okay. Amazon, that is the framework that is developed by Amazon is the bracket one. Again, this is also a Python based one, developed in Python. And Microsoft, what they are using Q#, which is developed using C#. And Azure Quantum is the cloud you can connect your Microsoft's quantum computer using Azure cloud. That cloud is called Azure Quantum. And John Doe company, they have developed these two strawberry fields and penny line. Here penny line is the one which you will use for machine learning. All the optimization problems, you just blindly can use this penny line. That does not mean that you cannot use Qiskit. Qiskit is also a very good framework. And Rigetti, D-Wave. Now, these are the one. And the Amazon bracket is, the beauty of this Amazon bracket is, using APIs, you can write your program in bracket using bracket framework, and you can run those programs either in one of the, you can run your programs in any of the IBM quantum computer or Google's computer, John Doe, anything. Those APIs are provided by the Amazon bracket. Okay. And just pass. What is meant by pass? PAAS. Actually, the services, let us stop from here. Let us deviate for 2 minutes from the quantum, and we will see what is happening in the industry. Actually, in the industry, main roles can be divided into 3 types. One is called the development role, the second one is called the testing role, and the third one is called the operational. In the developer, what you will be having, developers will be given on the problem, and there you will develop your programs to solve that problem. Testers will test the exactness for the problem, and once this is done, once your programs are working optimal up to our expectation, then they will be sent for operationals. Okay. Here, SaaS these three types, these three roles will form the SaaS, software as a service, SaaS. And the guys which will look after the hardware levels, that means hardware levels are installation of your softwares and dependents, everything, and these are all called the hardware levels, and these are called, we'll call it, even the cloud also we can call as PaaS, platform as a service. Just like in classical one, we do have quantum PaaS, that means quantum platform as a service, and this is how it has been, the architectural diagram, how first, if you come from top to bottom, like this, see, application wise, algorithms, framework, architecture, control, quantum and simulators, like that. This is how your IBM quantum PaaS has been aligned. Similarly, base, bracket, Azure and Google's. For every layer, there you need force. Without humans, you cannot do that one. Okay? This is how the quantum cloud platforms are there. Any doubts? Then how the future of quantum computing? Future means it is immense of future. By that time, I think all of our first year students, by the time you come out of your you are stepping out of this institution, there are ample of opportunities, either in the form of quantum programming developer, or in the form of quantum PaaS, or in the form of physics, mathematics, or some other thing. And these are the various generations. So far we are in the first generation. That means in the 2018 to 2028. We will go, by this time we enter into 2031. Huge quantum resources are in demand. Actually, in AML also there are 50 lakh jobs are there, but industry is not getting the full, well adapted persons. That is, they are not finding the good resource. If for AML it is the case, then think about quantum professionals. And this is the learning part you can take. For quantum computing problem, you should learn this one, and quantum mechanics few subjects only related to the QC. And these are not the domains. That means some other suppose if you in finance, if your problem definition is finance, means financial expert is needed. If it is in machine learning, means again for everything domain expert it must be there. And just like classical algorithms, we do have quantum algorithms, and these are all the basis. This Das, Joseph, Bernstein, Vazirani and Simon's algorithm, these are all the basis algorithms. And quantum Fourier transforms. Mathematics, what subjects are there, what topics are there in mathematics? Huh? Calculus? Okay, calculus. The thing thing is, what are the problem that is can be solved by using calculus, the same problem can be solved using linear algebra. You can keep that in mind. When you go into the linear algebra, I think in the next year or in the next semester you will learn about linear algebra. There you can find how to find the differential second order differential equations, how to solve second order differential equation using matrices you will learn. Okay? This Fourier transform, anybody from electronics and electricals? Anybody from electronics and electricals? No. This Fourier transformer, there will be some problems for you which you find it difficult to solve in some, again here one mathematical concept in one domain, say frequency time domain. If that particular problem is very hard to solve in that particular time, in that particular domain, the same problem by small manipulations, if you convert that frequency time domain into space-time domain, then it will be very easy. And that Fourier transform is used in cryptography. Especially Shor's algorithm is there. The Shor's algorithm is there, which breaks the current RSA algorithm, which is mainly used by banking transactions. Suppose if I want to book a travel ticket to somewhere and I want to pay through internet, means either I have to give my credit card details or debit card details, or I have to pay through internet banking. What it will do is, so far RSA, Rosen, some 3% have devised that algorithm. Because of arrival of this quantum computer, especially this Shor's algorithm, that RSA is under threat. They can easily buy in quantum networks. I think it is there. I have not included. There is a quantum technology slides. I will tell that one. Using this Shor's algorithm, I can break that RSA algorithm so that your bank, your identity credentials will be under threat. And this Peter Shor algorithm laid the foundation to increase or to why industry has identified the importance of emerging quantum technology from 1995, I think 1995, 96, between 1995. From that time onwards, rapid research has been conducted, and because of that rapid research, we are in a position to realize the potential of this quantum computer. And I hope by the time within next 3 years, that means by the time you step out of this college, you will be placed in as a quantum programmer or physicists or mathematicians. And these Grover's algorithm, these are all the things when you learn, after learning the basics, then only you can learn these ones. Please keep in mind. This Grover's algorithm is used for searching the data sets or unstructured data sets. You will learn about what is meant by structured data, unstructured data, and searching data in your normal data structures. And I told you this one, quantum teleportation, they are used mainly for quantum information passing from one place to another, especially in the space technology also they are using. They will use it. You will be having one session on this quantum teleportation. And super dense coding is a high, it needs quantum error coding also. It is a highly advanced coding. And entanglement, I told that entanglement, that is used here in super dense coding. And quantum key distribution in quantum cryptography, you will be told what is this quantum key cryptography. All right. Any doubts? And these are all some other advanced algorithms. Out of this HHR, arrow Hasseltine Lloyd, is the algorithm that is used for solving complex linear algebra solution. You will find. And variational quantum linear solver and this quantum approximation and optimization algorithms are mainly used for optimization problems. That is in QML, in hybrid model. Again, you will be introduced to that one also. And these are the few other algorithms, especially solely for QML process, quantum machine learning. You will learn about what is meant by support vector machine, everything you will learn in normal machine learning, and how it differs from how those support vector machines are neural networks or convolution neural networks. All these are how the processing is different from conventional to the quantum computer. These are the QML algorithms. And these are the various few resources that you can use to enhance your quantum computing capabilities. And these are at least everybody should have these. First you read this one, Quantum Computing for Everyone by Bernhard. And this is the Bible of the quantum computing. This one, Michael A. Nielsen and Isaac Chong. And remaining these two are not necessary. If you could, it's good you can go through this. And if possible, I request you can see the Transcendences movie, English movie, where you will introduce all those concepts and you can easily. Learning by visualization has more impact than by just learning by reading. So I request you, if possible, you can review this Transcendences movie. It is a very good movie. It elaborates all those properties, how the quantum computer will work